Which of the following statements accurately describes the use of Gaussian processes in machine learning? A Gaussian processes are primarily used for classification tasks, providing probabilistic predictions for class labels. B. Gaussian processes are solely designed for regression problems, offering a distribution over possible function values. C. Gaussian processes are versatile tools for both regression and classification, enabling probabilistic predictions. D. Gaussian processes are primarily used for dimensionality reduction, transforming data into lower dimensional representations. False. This statement is incorrect. While Gaussian processes can be used for classification, they are not primarily used for it. Their application spans both regression and classification tasks. Gaussian processes are flexible models capable of addressing both regression and classification tasks. They provide probabilistic predictions, allowing us to quantify uncertainty in our estimates. False. This statement is incorrect. Gaussian processes are not solely designed for regression problems, they are versatile and can handle both regression and classification tasks effectively. Gaussian processes are flexible models capable of addressing both regression and classification tasks. They provide probabilistic predictions, allowing us to quantify uncertainty in our estimates. True. This statement is correct. Gaussian processes are highly adaptable and can be employed for both regression and classification problems, providing probabilistic predictions that quantify uncertainty in the model's output. Gaussian processes are flexible models capable of addressing both regression and classification tasks. They provide probabilistic predictions, allowing us to quantify uncertainty in our estimates. False. This statement is incorrect. Gaussian processes are not typically used for dimensionality reduction. Their primary focus is on modeling functions and providing probabilistic predictions for both regression and classification problems. Gaussian processes are flexible models capable of addressing both regression and classification tasks. They provide probabilistic predictions, allowing us to quantify uncertainty in our estimates. C. Gaussian processes. Gaussian processes are a powerful non-parametric method for modeling functions. They define a distribution over functions, allowing us to capture complex relationships between inputs and outputs. Regression. In regression problems, the goal is to predict a continuous output variable based on input features. Gaussian processes are well suited for this task because they can model the underlying function relationship and provide uncertainty estimates for predictions. Classification. Gaussian processes can also handle classification problems, where the goal is to assign input data points to discrete categories. This is achieved by using a probabilistic model that outputs the probability of a data point belonging to each category. Gaussian processes are particularly useful when the decision boundaries between classes are complex or nonlinear. Probabilistic predictions. A key advantage of Gaussian processes is their ability to provide probabilistic predictions. This means that for each input, the model outputs a distribution over possible output values, reflecting the uncertainty in the prediction. Time series forecasting. Using Gaussian processes for time series forecasting allows us to capture temporal dependencies and make predictions about future values. Image analysis. In image analysis, Gaussian processes can be used for tasks such as object detection, image segmentation, and image classification. Their ability to model complex relationships and handle high-dimensional data makes them suitable for these applications. Robotics. Gaussian processes are valuable in robotics for tasks such as motion planning, control, and sensor fusion. They enable robots to adapt to changing environments and make informed decisions based on uncertain information. Drug discovery. Gaussian processes have been applied to drug discovery for tasks such as predicting protein ligand interactions and identifying potential drug candidates. Their ability to handle complex molecular structures and predict binding affinities makes them useful in this domain.